Every single day, organizations are hit by a tidal wave of customer feedback. Millions of individual data points flood in, creating a volume of information that is simply too massive for any human team to process. For decades, the primary tool used to catch and sort all this information has been the standard customer survey. The problem with these traditional forms is their rigidity. The data sits frozen in isolated departmental databases, requiring manual processing that slows down any response. This diagram maps out a dangerous chronological gap. The timeline of a frustrated customer plummets rapidly toward churn, while the timeline of manual data reporting lags far behind. Because of this delay, companies often review complaints weeks after the fact, attempting to recover patrons who may have already taken their business elsewhere. To close this gap, businesses are adopting experience management systems, or XM, which monitor and improve customer interactions using artificial intelligence. Gathering more surveys does not solve this structural delay. Strategic advantage now depends on the ability to interpret and resolve that feedback the moment it arrives, before the window for action closes. Imagine a shopper standing in a checkout line at a retail store. Frustrated, they pull out their phone and type a quick, open-ended complaint about the excessive wait time. The instant that submit button is pressed, the raw text enters Qualtrics, an experience management platform built to intercept and process feedback in real time. Without a human ever reading the screen, an AI tool called text analysis immediately scans the open-ended response to establish the context. This animated diagram shows how the AI breaks the text down. It fractures a conversational sentence into discrete, organized data points, categorizing the feedback by specific variables like store location and department. While the text is categorized, a second process called sentiment analysis assigns a color-coded value to the emotional tone of those variables, calculating the level of customer frustration. The system narrows in on the exact source of the friction. The variable for checkout speed flashes red, identifying wait times as the definitive cause of the negative sentiment. In a fraction of a second, the software has extracted both the logistical facts and the human emotion from a block of raw text, bypassing the need for manual reading. Comprehension is only the first step. The system now uses predictive intelligence to evaluate this single complaint against a deep archive of historical store patterns. This line graph maps out historical store performance. When the AI cross-references the current frustration level with past records, the new data point registers as a sharp spike, marking a clear statistical anomaly. The algorithm projects forward, calculating that if this specific checkout delay is ignored, customer churn at this location will likely increase by a distinct, measurable margin. Instead of compiling these findings into a weekly report for management to review later, the AI immediately initiates an automated workflow to actively intervene. It executes two actions at once. The system pings the local store manager with a direct recommendation to open another register, while simultaneously emailing a personalized apology and discount code to the shopper. This transition, from a single complaint to a targeted staffing change and a personalized response, was executed in milliseconds, rather than the weeks it takes for traditional manual review. When you scale this pipeline up from a single retail checkout to a global enterprise, the system is processing millions of these interactions concurrently. Healthcare providers analyze patient feedback instantly to adjust care quality, while banks use these exact insights to preemptively resolve service issues and stop account closures. This diagram illustrates the structural shift at play. Instead of a central bottleneck where analysts react to past damage, thousands of raw data points flow in continuously, routing them into parallel action pathways to optimize future experiences. Operating at this velocity does introduce new operational hurdles. Scaling automated decision-making requires strict guardrails. Organizations face two primary challenges for enterprise adoption: guaranteeing the secure privacy of customer data and developing responsible algorithms that remain transparent, fair, and unbiased. This highlights the role of the human in the loop. The machine does not replace executive decision-makers. It synthesizes the noise, providing the real-time support they need to make accurate choices. Organizations using AI to instantly turn feedback into strategic action operate with a speed that traditional survey models can no longer match.